Okay, so we have a fun little problem here. It says in elementary trig, you probably learn about the law of cosines for triangles of sides A, B, and C. That is, c squared equals a squared plus b squared minus 2ab cosine theta. Sorry about that, bless me. Okay, so I just drew down here. We have vector A, B, and C. And here is the angle theta. In this case, it's between A and B. And then over here, just so we're okay with that, this red angle, or I should say actually, it's not all that. This red angle is 180 degrees minus theta. Because 180 will get you the whole side, but then you're taking away this part when you subtract theta. Okay, cool. So hopefully that diagram kind of makes sense, at least for right now. Okay. Now, let's remember that A dotted with B is equal to the magnitude of A times the magnitude of B times cosine of the angle between them. Now, when we're saying the angle between theta, I want to talk about this, because this theta is not this theta. Imagine if we took A and we just moved it over here. We can move vectors. Now, the angle between A and B, theta, which is what I have highlighted, is this. 180 minus the theta there. So imagine if I just moved A over here. Okay? Hopefully that makes sense. That's the theta we're talking about. Okay. So we have A dot B is equal to all this stuff. Another important thing to know, and I'll make a note over this, is the vector C is what happens when you add vector A plus vector B. Okay, so this part, vector C, is just a vector A plus vector B. And I think that's okay to see. So we have this, and we have vector C equals vector A plus vector B. I'm going to multiply both sides by vector C. But I'm going to do something kind of funny. I'm going to rewrite this C. Oops. I'm going to rewrite this C as just this, because they're equivalent. So there's no reason I can't do that, right? So we have C dotted with C, which is just C squared, is equal to A plus B dotted with A plus B. And if you FOIL, you'll see that vector C is equal to A squared plus B squared plus 2 times A times B. You can FOIL this, and you should see that's, if you multiply this out, you should see that's what you're going to end up getting. Okay? But this part, A dotted with B, I'm going to replace that. I'm going to replace this with this, because they're equivalent, so I can do that. So C squared, I'm going to just drop the arrow notation because it's just going to be a little bit simpler, I feel, at this point, is equal to what? A squared plus B squared plus 2 times A times B times cosine of the angle between those two vectors. Now, what is the angle between the two vector? That was this little tangent I went on earlier. If you imagine if we move A over there, what's the angle between... 1 second. Okay, sorry about that. I had some people come by and the dogs kind of lost their mind. Anyways, so what I was saying, I think at the end of the video, is if you imagine moving A over so that the two tails are connected, the angle between them is the 180 minus theta. So what I'm going to do here is I'm going to replace this with c squared equals a squared plus b squared plus 280 times a times b times cosine of 180 degrees minus theta. Now the 180, that's just going to be a shift if we think of our unit circle. Let's see if I can draw a decent little circle. If I have a point here, and I go 180 degrees to here, instead of it being 1, it's going to be negative 1. So the 180 basically is just going to change the sign of our answer. So we could think of this as c squared equals a squared plus b squared minus 2ab cosine of negative theta. And cosine is an even function. So what that means is cosine of negative theta is just cosine of theta. Goes away. So c squared equals a squared plus b squared minus 2ab cosine theta. And there we go. We proved this little formula from trig with what we know about vectors and what we know about the dot product. We did a little bit of algebraic manipulation, and we moved A over a little bit. That was a little tricky, I suppose. And yeah, we have one of the equations you get from the law of cosine. So pretty cool.